Hello guys, let us take a look at this question. It says that a block of mass 4 kgs is kept on the ground and the coefficient of friction between the block and the ground is 0.8. Okay, so basically what they're saying is that this is a 4 kg block, not 2 kg, 4 kg block, and the coefficient of friction basically, okay, they're saying that nu is equal to 0.8. Fine. Then an external force of magnitude 30 Newton is applied parallel to the ground. So this is a force F is equal to 30 Newton and it is applied parallel to the ground. Fine. Resultant force exerted by the ground on the block is. Okay, so we have to find out what is the resultant force exerted by the ground. So first of all, okay, although the question is simple, but let's see. So first of all, free body diagram. Okay, let's draw that. Okay, so let's mark all the forces and then we'll see what is the resultant force by the ground. So first of all, okay, what will be there? So first of all, we will have mg, right, in the downward direction. Okay, then normal reaction, okay, will be exerted by the ground, okay, on the body in the upward direction. Then we will have basically, okay, friction F, which will act in this direction. And now see, before, okay, we find out, okay, whether what is the value of friction. Okay, we first need to find out, okay, what is F max. Okay, what is F max? F maximum frictional force will be nu times n, right, normal reaction. So that is 0.8 into normal reaction is what? So you can say n is equal to mg, right? N is equal to mg. Okay, so this is okay, in vertical direction. If you balance the forces, you get this. So what is mg? So mg, so this is 4 kg, right? So 40 newtons. So this is going to be 4 into 10 of 40 newtons. Okay, 40 newtons. So I can say, so come back to F max. F max will be nu n. So it will be 0.8 into 40. So this will be how much? 32. So 32 Newton is the F max. Now if, okay, the external force that we are applying, this one, okay, F is equal to 30 Newton. If the external force is greater, then only the block will move. Okay, otherwise the frictional force is more. So block will be at rest. So in our case, okay, the external force 30 Newton, okay, is less, okay, than F max. Okay, so basically this means that the block is at rest. Okay, so block is at rest. So that means what is the actually the frictional force that is acting? Because friction we know is a self-adjusting force, right? So frictional force, okay, will be how much? I'll write it here. So friction force will be equal to F only, right? So F was acting here, and frictional force was acting here, and you had normal reaction in this direction and mg in this direction, right? These were the forces. And so so in our case, F is equal to capital F, and that will be equal to 30 Newton. So a frictional force we have found out, okay, and now see what they are asking. They are asking us, okay, what is the resultant force that is exerted by the ground? That means, okay, which are the forces exerted by the ground? So ground is exerting the normal reaction. Okay, let's mark them with a different color. Okay, what are the forces exerted by the ground? So one is your normal reaction, okay, which is acting in this direction, normal reaction. Okay, and we found out normal reaction is 40 Newton, right? 40. And then the next force that is acted by the ground is the frictional force, right? So it will be this one, frictional force, which is equal to 30 newtons, right? So we have these two vectors, okay, and the angle between them is 90 degrees. So we can easily find out, okay, what is the resultant force? F resultant, you can say F ground is equal to root over, so it will be 40 square plus 30 square, right? And then you will have 240 into 30 cos theta, but cos theta cos 90, right? So that will become 0. So we will get 0 in the third term. So we will have 40 square plus 30 square, that is, so you basically this answer will be 50, right? F resultant due to ground is equal to 50 Newton. So a correct answer, resultant force, becomes 50 Newton in this case. Thanks for watching.